Why don't we practice a few questions using the quotient rule now? Let's say we have something like this. F of x equals 3x cubed minus 4 root x all over 5x minus x to the 8. That's definitely a quotient, right? So let's see what the derivative is. We're going to, of course, use the quotient rule to find this derivative. How does it go again? The quotient rule says we do the derivative of the numerator. Let's do that. What is the derivative of this numerator? It's going to be, well, 3 times 3 is 9, x squared minus, to do this derivative, we'll pull the number out front and then multiply by the derivative of this, which is 1 over 2 root x. All right, so what I have in the brackets here represents the derivative of the numerator. Now the quotient rule says you do the derivative of the numerator times the denominator left alone, and then minus, remember the product rule, it's plus, but this is quotient rule, so we use minus. Now we leave that alone, the numerator, just recopy it, and then multiply by the derivative of the denominator. To do the derivative of this, it's, 5 times 1 is 5, minus, the derivative of this is 8x to the 7. And then to finish it off, we just take whatever the denominator is and square it. That's what the new denominator is. Now I don't want to simplify this or even try to, so it's perfectly fine if you just leave your answer there, all right? Okay, good. So let's try another one. How about something like this? F of x equals 1 plus cos x all over 2 minus sine x. That's a quotient, so to find the derivative, we use the quotient rule. So the quotient rule says to do the derivative of the top, which is 0 plus, what's the derivative of cos x? Minus sine x. And then we leave this alone. Quotient rule, we have a minus next, right? And then we recopy the numerator times the derivative of the denominator, which is 0 minus cos x, all over the square of the old denominator. So I just recopy 2 minus sine x and throw a square on it. Now we could definitely probably clean this top up. Why don't we clean it up? Let's see here. This 0 here is irrelevant. This 0 is irrelevant. So basically we have minus 2 sine x. Minus sine x times minus sine x is plus sine squared x. Over here we have a minus 1 times a minus cos x, so it's plus cos x. And then we have a minus cos x times another minus cos x, which is plus cos squared x. And that's all over 2 minus sine x squared. Now notice here that I have a sine squared x plus cos squared x, right? Remember, that's equal to 1, right? Sine squared x plus cos squared x is 1. So why don't I write that out front? 1. And then I'll recopy these other two terms. Minus 2 sine x plus cos x. And that's all over 2 minus sine x squared. And there's your simplified answer. So you could stop here if you wanted to just find the derivative without worrying about simplifying anything. But if you had to simplify it, I would take it down to here. All right. So let's try another one. Say number 3 here. F of t equaling to t cos t all over t squared minus 1. Now the interesting thing about this one is certainly it's a quotient rule because it's a quotient of two functions. But notice on the numerator here, this is actually even a product, right? So we're going to be combining quotient rule and product rule here all into one question. Why don't I go a little bit slower on this one for that reason? So instead of doing the derivative right away like I've been doing, why don't we just use some prime signs? So to do this derivative of this quotient, we do the derivative of the top times the bottom left alone minus the top left alone times the derivative of the bottom all over the bottom squared. So that's our first step. We're not done the derivative yet, though, because we still have to do this derivative and over here as well. This derivative is easy, though. Now, the point is this derivative here is actually going to be product rule. So we have a product rule within a quotient rule. You'll get used to these kind of things soon enough. How do we do the derivative of this? Well, here's one factor times the other factor. So the product rule says do the derivative of the first. What is that? T, which is 1, times the second factor left alone, plus the first factor left alone, times the derivative of this, which is minus sine t. And then I'm going to recopy this, t squared minus 1, recopy all of this. There's no derivative sign on this or this, so there's nothing to be done. That's why I recopied. And the derivative of this here is 2t minus 0. So I'll just write 2t. And that's all over t squared minus 1 squared. All right, so this could be, why don't we just clean it up a tiny bit here. This is really cos t minus t sine t. Let me just erase that a tiny bit. Times t squared minus 1 minus 2. Notice 2t times t here. So minus 2t squared cos t all over t squared minus 1 squared. You could probably multiply that out and do a little bit more, but I'm just going to leave it right there, okay? I don't want to waste time doing too much algebra. Our main goal is to be getting used to those derivatives. So I think this is a little bit of an important example. Make sure you understand it. Because like I said, it's a product rule within a quotient rule. We do the quotient rule, but then over here on this term right here, we have a product rule within it. So we have to apply product rule there. But overall, it is a quotient rule. All right. Let's try another. How about this one here? I can't remember what number we're on. I guess it'd be number 4 now. And it would be, how about this question? S of theta 1 over root theta plus theta sine theta. Now again, we have a situation where we're doing a product rule. Let me just fix this a little bit. Sorry, I meant we're in a situation where we're doing quotient rule. This is definitely a quotient. But notice over here we have a product, right? So to do this derivative, we'll have to think about that again. How about this time I go a little bit faster, though? The derivative of this is 0 times this left alone. And then the minus sign of quotient rule. Now we leave this 1 alone. And we do the derivative of this part. The derivative of root theta, that's easy. It's 1 over 2 root theta. And then plus the derivative of this, which is by product rule, right? So to do the derivative of this, we do the derivative of theta, which is 1, times sine theta left alone, plus theta left alone, times the derivative of sine theta, which is cos theta. And that's all over root theta plus theta sine theta squared. And that's great. I guess one thing we can do is this is 0 times all of this. So this actually just all disappears. And this minus 1 is, this minus sign could be distributed across to all of these terms here. So why don't we do that? We get, I guess we would have minus 1 over 2 root theta and then minus sine theta minus theta cos theta. And that's all over the square of the bottom there. And that's good enough for simplifying. So there we go. We did another example where we had product rule within a quotient rule. And we just did it right away. We didn't take that extra step. You can do it the fast way or the slower way. Both are good. Just be aware, though, like if this was a minus sign here, what if this was a minus sign? Then if you would write a minus sign here, you'd replace this with a minus sign, right? And that issue I talked about it before is like you got to put brackets, an extra set of brackets around here, right? Because this minus sign is going to affect this plus sign later on. So that, in other words, this minus sign here would actually be a plus then, right? So if you forget those extra set of brackets, you will not make this change, and that'll become a problem, right? So I hope that makes sense. I hope I didn't say anything. I hope I didn't make a mistake there, but that's fine. So just keep that in mind, and I think that's enough practice for that.